Lately the whole internet has been buzzing, saying China discovered a planet covered in gold, and that it sits right in the asteroid belt of our solar system. Some people even estimate that if we could tow it back to Earth, every person on the planet could get more than 20 tons of gold. But the real story may disappoint you. According to the latest spectral analysis and modeling estimates, Psyche has an average density of only about 4 grams per cubic centimeter, less than half the density of pure iron. That means it cannot be a solid ball of gold. The amount of gold on it is far lower than people imagine. In reality, Psyche is essentially a rubble pile made of rock, iron, nickel, metal and trace precious elements. As for the gold content, at most it makes up about 1/millionth of its total mass. If you want, gold mining alone will not do it. You would have to melt down the entire asteroid in a furnace just to separate out the precious metals. Since the gold is so scarce, why did NASA spend $1.2 billion to send a spacecraft? For scientists, gold is actually the least valuable thing about it. What truly matters is that it can unlock the secrets of how planets formed in our solar system. About 4.5 billion years ago, the solar system was still a chaotic protoplanetary disk. Back then Psyche was not alone. It was on its way to becoming a planet and had already completed the key process of differentiation. In simple terms, heavy metals sank to form the planetary core, while lighter materials like rock floated upward, creating the mantle and crust. If everything had gone smoothly, it might have become a full rocky planet like Earth. But things did not go as planned. Before Psyche could fully grow, it was struck by multiple massive collisions. Several, even dozens of large protoplanets slammed into it. These impacts did not reduce it to dust. Instead, like peeling an onion, they blasted away hundreds of kilometers of rocky outer layers and tore apart much of its deep silicate mantle. In the end, Psyche became like a peach stripped of its flesh, leaving only the pit, which is this exposed metallic core. Over the following billions of years, it endured countless smaller impacts. The once dense metal was fractured and broken apart, creating cavities and cracks throughout. That is why today we see a metallic rubble pile with a density of only about 4 grams per cubic centimeter. Because of this, Psyche is the only planetary core humans can directly observe so far. Even though we live on Earth, we understand less about Earth's interior than about outer space. Earth has a radius of about 6,400 kilometers, yet the deepest humans have ever drilled is the Kola superdeep borehole at just 12.2 kilometers, not even penetrating through the crust. The enormous blazing metal core beneath our feet that generates Earth's magnetic field remains largely unknown to us. We can only infer its structure from seismic wave reflections, like trying to guess what is happening inside a house from behind thick walls. But Psyche has no mantle or crust blocking the view. We can observe it directly with spectrometers, gravimeters and magnetometers. Studying Psyche is essentially like taking a close-up look at Earth's core. Many people wonder, what proves Psyche is really a planetary core? The answer lies in the Widmanstatten patterns on its surface. These patterns are metallic crystal structures that form only under extreme conditions to create the interlocking iron-nickel texture. The metal must cool at an incredibly slow rate of 1 to 10 degrees per million years. Such slow cooling can only occur when insulated by a thick mantle. These patterns are the strongest evidence that Psyche was once a planetary core. To travel hundreds of millions of kilometers to study this distant core, NASA invested $1.2 billion, including a cutting-edge technology called the Hall thruster. That faint blue glow at the back is not from traditional chemical fuel burning. It comes from xenon ions being accelerated. The thrust is extremely gentle, barely enough to lift a sheet of paper, yet like a silent presence in deep space it keeps accelerating, eventually pushing the spacecraft to speeds of tens of kilometers per second toward its target, ensuring it can safely arrive and orbit Psyche. The real scientific payoff of this mission is solving long-standing mysteries about planetary cores. First, scientists want to understand the density gap in Earth's core. Seismic data show that Earth's core is about 10% less dense than pure iron nickel, which means it must contain lighter elements like sulfur, silicon, and oxygen. By studying Psyche, this exposed core, we can directly measure the proportion of these light elements, and finally clarify the original building materials of the solar system 4.5 billion years ago. More importantly, by examining how Psyche's core cooled and solidified, scientists can reconstruct the full process of a metallic core evolving from liquid to solid. This is not only about understanding planet formation, it also helps us predict the future of Earth's magnetic field, and whether Earth could one day lose its magnetic shield as Mars did, becoming barren. At present, the Psyche spacecraft has been traveling through space for more than 2 years. It is expected to fly by Mars in May 2026, using a gravity assist for its final boost. Before heading into the depths of the asteroid belt, If all goes well, it will arrive in August 2029. At that time, the spacecraft will gradually move closer in 4 orbital phases, eventually flying just tens of kilometers above the surface, using a neutron spectrometer to fully map its chemical composition. When you stand 3.5 billion kilometers away in deep space, looking down at this gray metallic remnant, you realize that gold, which is extremely rare in Earth's crust during the earliest stages of the universe, was merely a minor byproduct of heavy metals sinking. Psyche's true value has never been gold, but the 4.5 billion year history of solar system evolution it carries. Those blazing beginnings, the slow cooling, the secrets of light elements, will finally shift from speculation to solid data.